Using the unit circle with trig identities. The unit circle has a radius of 1. Also, any point on the unit circle corresponds to an xy point. Now, the x-coordinate of this particular xy point, given a certain angle, is going to be cosine of theta, your angle measure, and the y-coordinate is always going to be sine of theta. So we can use this information to easily find the other 4 trig functions of this particular angle measure. All right, now for some examples. If theta is equal to 5 pi over 4, we should be able to use our unit circle to find all of the trig functions. So the first thing, our x-coordinate is going to be cosine. So cosine of 5 pi over 4, if you refer to your unit circle, it is the x of 5 pi over 4, which is negative square root of 2 over 2. So that's your cosine. And then sine of 5 pi over 4 is going to be equal to the y value at that same angle measure, which is also going to be negative square root of 2 over 2. Okay, now the next thing we're going to want to find is tangent, because we can use these two to find the rest of them. So tangent of 5 pi over 4 is going to be equal to sine over cosine, which is just going to equal 1. And then if I find my cosecant of 5 pi over 4, that is the reciprocal of sine. So it's going to be 1 over negative square root of 2 over 2, which is actually going to give us negative 2 over the square root of 2. And then you might want to rationalize the denominator, so you multiply by square root of 2 over 2, square root of 2, giving you the final of negative square root of 2. So that's your cosecant. Then your secant is similar, 5 pi over 4, except it is the reciprocal of cosine. So again, I'm going to flip and have 2 over square root of 2, and it's negative still for the cosine. Then I rationalize square root of 2, giving me negative square root of 2. And the last one is cotangent of 5 pi over 4, which again is going to be the same idea. It's still going to be the reciprocal of tangent. The reciprocal of 1 over 1 is still 1 over 1, so cotangent is also 1. And there is are your 6 trig functions of 5 pi over 4. Next, suppose theta equals negative pi over 3. So on this one, when we look at the unit circle, we're going to go clockwise to the negative pi over 3 part. And so sine of theta is going to be negative square root of 3 over 2, because that is our y value at that angle measure. Our cosine of theta is going to be the x value at that angle measure, which is 1/2, positive. Okay, so now we're going to use those to find the rest of them. So first thing I'm going to do is find tangent of theta, which is just sine over cosine. So that would be the square root of 3 over 2 divided by 1/2. And so we invert and multiply, giving me square root of 3. But remember that sine is negative, so I should put that there, making our tangent negative square root of 3. And then I'm going to just go ahead and find cotangent right now, because all I have to do is flip the tangent. So that's going to be negative 1 over square root of 3. And I need to rationalize, so I'm going to multiply by square root of 3, square root of 3, giving me square root of 3 over 3, and it's negative. So that is cotangent of theta. Next, I want to find cosecant of theta, so that is the opposite of sine, so that's going to be negative 2 over square root of 3. And again, we need to rationalize here, so square root of 3, square root of 3, giving me negative 2 square root of 3 over 3. And that is your cosecant. And secant of theta is going to equal the inverse of cosine, which is 2 over 1, or 2. And that is your secant value. So those are your final answers for the 6 trig functions of negative pi over 3. Okay, now we want to find the exact values of the other trig functions, given this information. So we know that sine of theta is 6 over 16. We are not going to simplify these. We're just going to leave them as that. So sine is 6 over 16, and cosine is positive. So what that tells me is if I'm going to create a triangle with my theta being my angle measure, then I'm going to be going towards the right on my axis, and then I'm going to go up because the sine is also positive. So that is going to be the triangle I'm looking at. And I know that sine, so opposite over hypotenuse, is 6 over 16. So that tells me that 6 over 16 is right there. And then I just need to find everything else. So how am I going to find my cosine? Well, cosine is going to deal with this value right here. We'll call it b for now. Well, that's just going to be the Pythagorean Theorem. So we know that b is going to equal, b squared is going to equal the square root of 16 squared minus 6 squared. So if I solve that, sorry, that's going to be b when you take the square root. B is going to equal the square root of 220, which simplifies to b equals 2 square root of 55. So if I know that's b, then I can find cosine. Cosine is positive, as we know, and that's how we drew it this way. Cosine of theta is going to equal adjacent to square root of 55 over 16. And like I said, we're not going to simplify these because we're talking about a specific triangle. Okay, now we want to find tangent. So tangent is going to equal sine over cosine. So that's going to be 6 over 16 divided by 2 square root of 55 over 16. Okay, so then if I invert and multiply, I'm going to get 6 over 2 square root of 55. We are still going to rationalize our denominators though. So when I rationalize this denominator, I need to multiply square root of 55, square root of 55, giving me 6 times the square root of 55 over 2 times 55, which is 110. So that is your tangent. And now cotangent of theta is going to be the opposite. You're going to flip these around. So I'm just going to go back here and just flip these two numbers over. And that would be 2 square root of 55 over 6. And that would be your cotangent. And finally, we want to find cosecant and secant. Cosecant of theta and secant of theta are reciprocals of sine and cosine. So cosecant, I'm going to flip sine, so that's going to be 16 over 6. Secant of theta is going to be the reciprocal of cosine, so that will be 16 over 2 square root of 55. And again, we're going to need to rationalize our denominator, so multiply by the square root of 55, square root of 55, and I get final answer of 16 square root of 55 over 110. Final answer. For this last example here, we want to start by drawing our picture. We know sine is negative and cosine is negative. So our triangle is actually going to go cosine is negative and sine is negative. So our triangle is going to be right there with our theta right there. So cosine of theta is going to be 10 over 15. And again, this time we're going to be looking to find a. So a is going to equal the square root of 15 squared minus 10 squared. So a is going to equal the square root of 125, which simplifies to 5 square roots of 5. So that is going to be my a, so I can easily find my sine of theta equals 5 square roots of 5 over 15. And it's negative because we know sine is negative. So there's my sine, and I have cosine, so I can find my tangent. Tangent of theta is equal to sine over cosine, so that's negative 5 square roots of 5 over 15 divided by negative 10 over 15. Invert and multiply gives me positive, because double negative, 5 square roots of 5 over 10, and that is simplified. Well, technically we could simplify further, but since we want the exact answers there, we're going to leave the triangle as it is. And then the next one, cotangent of theta is equal to the inverse of that. So I'm going to flip that over, and I get 10 over 5 square root of 5. Now this time I need to rationalize, so I'm going to multiply by the square root of 5, giving me 10 times the square root of 5 divided by 5 times 5, which is 25. Because this right here becomes 5, so 5 times 5. All right, and the next step is the cosecant of theta, which is the inverse of sine, and secant of theta, which is the inverse of cosine. So cosecant of theta is equal to inverse of sine, which is 15 over negative 5 square roots of 5. And we need to rationalize, giving me 15 square roots of 5 over 25, and that's negative. And finally, the inverse of cosine is negative 15 over 10. And that's your final answer. So those are your notes over using the unit circle with trig identities to understand the unit circle. Go through the practice problems. Make sure that you can find the different functions given different types of angles. And then you can prepare for your quiz over the material.